Good morning. Today we are continuing 7.4, solving logarithmic equations and inequalities. So in our first example, we're going to solve a logarithm where we're looking for the variable x. Alright, so our first thing to do is convert it to exponential form. So right now we're log base b of y equals x. And we're going to go from there to y equals b to the x. Alright, so I'm going to label my pieces just left and right. B is 36. My y is x. Again, don't get confused by it. It's just a placeholder. And my x is 3/2. So when I convert y equals b to the x, y is x, b is 36, and x is to the 3/2 power. Alright, and then you plug that in, and you get 36 to the 3/2 power is 216. There you go. So that's our first way to solve logarithms. Now, very similar to exponential equations, if we have the same base with logarithms, we ignore the logarithm and just solve the x and the y. So you see there's same base there and there. So then they just solve x equal to y. So, for example 2, we see that they have the same base. Alright, so we ignore the base, and we just solve x squared minus 4 equals 3x. Alright. So, I'm going to bring the 3x over. X squared minus 3x minus 4 equals 0. Factoring. Okay, so factors of 4 that add the negative 3. I'll have negative 4 and positive 1. So x plus 1 times x minus 4 equals 0. And then we solve. So x plus 1 equals 0. X minus 4 equals 0. So then we to get x equals negative 1 and x equals 4. Alrighty, so we can't have a negative in there. So we end up with x equals 4. Alright, because then if you check it, alright, so I'll do a check for this problem. Alright, so if I substitute 1 in, so I get log base 2 of negative 1 squared minus 4 should equal log base 2 3 times negative 1. This gives me 1 minus 4. Alright. Okay. Log base 2. Alright, so that checks out, but this is an extraneous solution. So plug into calculator and you'll see that it doesn't work. So extraneous. Alright, which means it's a solution that satisfies the work that we did, but it's not an actual solution to the problem. So this is x equals negative 1. Alright, now I'll do x equals 4. Then we get log base 2, 16 minus 4. Alright, plug that in, you both get real answers. So there we go. So 4 works. And that's why that works there. Alright. Then we have our property of inequality. All right, so if the base is greater than 1, so it's positive, it's greater than 1. All right, and our x is greater than 0, so our x is positive. Then we have this rule right here. Okay, but if the base is greater than 1, x is greater than 1, then we have this, then we have to do that right there. So if log base b of y is less than x, we have to do 0 is less than y less than bx. Whereas when it's greater than x, we just get y is greater than b to the x. All right, so our first one, we'll play to that, and then our second part of that, we'll play to that. Excuse me. Example 3. Okay, so it's greater than, which means we'll convert it. So we're going to go y is greater than b to the x. So my b is 3, my y is x, and then my b and my x is 4. So x is greater than 3 to the 4th power. So that means x is greater than 81. Now the other one, less than, so we have to do 0 is less than y less than b to the x. So we have my base of 2, my y is actually x, and then my x is 4. So we have 0 less than x, which is less than 2 to the 4th power. So 0 is less than x, which is less than 16. So this has multiple answers. So this is the example 3. So anything that's greater than 81 works for 3a, and for 3b, it's got to be between 0 and 16. Moving on. So we have two logarithms set equal to each other, or inequalities to each other. It's going to be kind of similar. So we have greater than right there. We're going to do x is greater than y. If we have less than, we'll do x is less than y. So here we have greater than, same base. So x plus 3 is greater than 2x plus 1. And then we solve. So subtract x, 3 is greater than x plus 1. 2 is greater than x. I don't like looking at it like that, so x is really less than 2. Alright. For b, I have the less than or equal to, and I have same bases. So 3 minus x is less than or equal to x minus 1. Alright, so that one goes with that one. This one goes with this one. Solving. 3 is less than or equal to 2x minus 1. Four is less than or equal to 2x. So I get 2 is less than or equal to x. Again, don't like looking at it like that. So x is greater than or equal to 2. And that's all we have, folks. Let me go back to the top and do a quick little review. If you have a logarithm, you're just looking for the x in this location. You're going to convert it to exponential form and solve. If we have two logarithms equal to each other and they have the same base, then we just say x equals the y and we solve it. And then we have our property of inequality for logs. This is when there's a logarithm on only one side of the inequality. So you follow the rule for that. And then for logarithm functions, if there's a log on both sides and they have the same base, you just follow the rules. If it's greater than, just set the pieces that aren't the bases equal or greater than each other and solve. And then on the other side, we have the less than or equal to, and the same thing, and just solve the inequalities out. All right. Questions? Let me know.